Hello. All right. This session, I'm gonna go through token. I'm gonna go to the token CTF challenge. So we last worked through telephone. I have to push this up. Okay. Let me go ahead and All right. First, we have to do some housekeeping stuff and just modify some of what we had from the last. I'm also probably gonna take this out and bring in this token contract. Um, we have some issues with a contract, so let's degrade these progmas and then make sure in our config we have these degraded. Okay. So let's look at the objective, see if we can set up our test cases first. So the goal of this level is for you to hack the basic token contract below. You are given 20 tokens to start with, and you will beat the level if you somehow manage to get your hands on any additional tokens, preferably a very large amount of tokens. Things that might help. What is an odometer? Okay, so already mentioning odometer, I'm pretty sure I know what this one's going to be about. It's likely going to be an integer overflow. Um, yeah. So the idea is in an odometer, once you hit, let's say you hit the max level, it really will just start back again over. Well, actually, this wouldn't happen from miles per hour, but if you exceeded the limits of an odometer, all it does is reset. This is a good example right here. Like the mileage. Once you hit this mileage right here, it's just going to reset all the way back to zero. Um, Set to zero. Yeah. So with this challenge, it looks like we degraded to 0.6.0, and I'm pretty sure integer overflow checks aren't introduced into .8, I believe. Yes. No, no, no. Oh, maybe that's it right here. Yes. So I believe in 0.8 is when integer overflows were checked. Um, and this kind of gives hints to the answer right here. Let's see. Yeah, so the default is to throw an error now in .8, which is what's used mostly, which can still actually be a vulnerability in smart contracts. Even though there's overflow and underflow checks, it will revert, and there are cases where you may not want a revert to happen. So essentially, if you could put in input that would DOS the contract, which is just provide a denial of service situation, you basically have use an integer overflow bug. But back before .8, you have actual overflows where if you know, go past the limits of the space that's allocated, then you will essentially have an overflow. And what that looks like is like, say, we have say we have like a uint 8, for example, and the number is 255. Um, the max space that can fit in a uint 8 is 255, and so if we go and add 255 plus 1, it would just overflow back to 0. So what we're going to do here is, so we have initial supply, transfer. I'm going to go into this contract. So we have a balance, we have total supply. We want to make sure we get more transfer than we're allowed to have. So we start with 20, and we want a lot. So let's see. We have 20 tokens. We want to transfer some tokens from an address to another. And if require balance, so if we send some tokens, who has to end up with what? Honestly, we can send tokens to ourselves. Yep, so we can put our own address in for this. We can put a value of 30, or we can put a value of 21. So we're gonna have 20 tokens, so let's put 21. And once we hit once we basically we're gonna underflow, we're gonna end up with a lot of tokens. And our balance of message.sender, let's go to value, that's gonna be really high, and then balance of the to address is going to equal to that really high value. We're going to return true. So we don't even need an attack contract for this. We're just going to use an externally owned account, and we're just going to pass in an address, which is going to be ourselves. There's no check to make sure we can't use our own address for this. So let's go ahead and give this a shot. So let's go to EOA attack script. Well, first we have to do a few things. We have to get a new instance, which is a new smart contract for this contract here. I'm not sure if I have to approve. Okay, we have an instance address. We have a few things. Token contract. We have an attacker, which is me. We have a contract address, and we don't want consecutive wins. We want to see balance. Yeah, let's see the balance. And what I want to make sure is expect the balance to be greater than or equal to more tokens than we originally had. So let's do some outrageous number like 1,000 tokens. Okay, so we have the um, token contract. The attack flow is going to be, let's split this. So the attack flow is going to look like this. We want to first, let me delete this. So first we want to call transfer function and list our own address as the token, as the to address. And then we want to, well, actually, no. First, I want to see balance of my attacker address. Let's do step 1. Step 2, we want to call the transfer function and list our own address as the to address. And then step 3, we want to grab the balance of after the exploit. Or malicious transaction is called. And then here in our test case, we are just confirming that we received way more than the original 20 we were allocated. So I'm assuming when I first called this, my balance should be 20. Considering that's what the contract said it was going to do. You're given 20 tokens to start with, yeah. So I'm assuming there's another contract that's allocating my 20 tokens, and we're going to see what we can do with that. So let's set this up where first we change this name to attack token. Okay. We should be good here. Should be good here. Let me compile to make sure we're good. Oh, let's change our node version first. All right, so we're good on our compile. We should have these contract ABI already ready for us. Yep, contracts token right here. And what we're gonna get is, let's get contract at token. Contract address, we're good, we're good. Okay. So let's first call the balance of with my address. So let's call let it's public view. Let, or let's say balance. Or no, we want old balance. or original. We want our original balance to be await token contract dot get balance. Or no, balance of. And then we're going to pass in my address. Should be a type of type address. And then after that, we're going to call this transfer function. Transfer. The to address is going to be attacker dot address, and the value is going to be ooh. I honestly don't know if I just throw it in as 21. We'll see. Or maybe I should look it up. Yeah, okay, we can do this right here. So let's do 21. Oh, wait. Let's do 22 because I think that might, the odometer might be set to 0, or our underflow might set to 0. So remember, um, once we hit 0, right, that's going to be, or maybe, no. Once we hit 20, yeah, I think once we hit, we'll just put 22 so it'll be stay at a high number. Um, yeah, this will be correct. So we're gonna do that, and then let's also await this receipt. And actually, I want to get in the habit of viewing this receipt. Okay. So we're going to get the transaction, and then we're going to get the receipt for that confirmation of the transaction. And then let's also set this balance that we have up top. Remember, we're not going to have to initialize this anymore. So let's set this balance equal to await token contract dot balance of, and do attacker address again. So this balance should be greater than or equal to 1,000, because it's going to be a really, really high number. But we shall see. So let us run this. What is this test? And we want to change this to token. Actually, let's do the autocomplete because I may have spelled it something wrong. There we go. Too many arguments in contract constructor. It's because we did the wrong one. We were supposed to do externally owned account. Let's try that. Did I not await somewhere? Hmm. Okay, so did this thing actually transfer? Because I'm not seeing this be a contract call. Okay, so we have original balance here. And get the balance of the attacker address. We want to transfer to our attacker address. Oops, not this one. deployed, or it's not deployed, but connected. So I'm trying to send myself some of this balance. Form exploit works, but the transfer call doesn't look like it happens. And I'm pretty sure we call the right transfer. Okay, let's look at MetaMask and see what were some of the latest. This so it says this transfer was called. It says it was successful. Hmm. And it looks like nothing was returned. But it was a successful call, so um my address should have this value. Return true. How do you review receipt details? Hmm. The Okay, let's try this again and just see what happens. Hmm. It's still 20 after the transfer. So let's see what's happening. It's successfully running. Balance this value is greater than equal to 20. 0, that's true. So what if we try a really high number? Or is this number even registering? Okay, let's see. Underflow. It's not working. If I do need to create an tag contract, hmm. Mhm. Let's see if this transaction worked. What do we get this time? Okay, so did work. Call the transfer function. We just don't know what that state looks like. What happens if I just do something silly like 5? Do we even get a response there? Okay. Yeah, so let's try another an attack contract. I think what's happening is we're just offsetting the overflow. I think we're just sending it back to ourselves. That's what I think. So let's try and create an attack contract. And what we're going to do is we're going to import token. We're going to change this to token and then token contract. Let's make this underscore token contract. Okay. That constructor should be good. What's the issue? Okay. Got token contract here. And we're going to call the transfer function. And our attack externally owned account and a value of let's try this. This doesn't need to be payable. And we're going to do function u value. We're going to pass in this attack address again. Be public. And then it's going to call the token contract balance of, and let's throw that attack address in here. And this is going to return uint. This is good practice because we're essentially just calling this. Oops. Actually, we don't want the attack. We can do that outside of this. Or no, no, no. You go back. This address. Or should it be this dot address? Yeah. Oh, let's address this. Okay. Issue function can be restricted view. Let's actually try multiple attacks in case this doesn't work. So, how to cause an overflow or underflow solidity. Yeah. Okay, so with that logic, if we just did like 23 for one of them, let's do attack 2. Let's just do 2000. Let's just do max equal to it. So 20. We have 20 tokens. Minus 21. Let's leave it -1. Then let's also do pack 3. And we're going to subtract it by the max. Hmm. Sender. If this is this should work because the message.sender, which is the contract minus that value, will be greater than or equal to 0. It's going to start off at 0. So one of them should just be like -1. Let's do attack 4. Wait a minute. Once I subtract and send that to someone, my value should still be pretty high. All right, let's try this. So we're gonna copy some of this here. Honestly, gonna copy a lot of this. And hacker address is good. Contract address is gonna be this. attacker contract factory. We have attack. Yep. Deploy. Attacker contract. Um. Oh, that's right. That's because this is a constructor. Okay. Because we're passing in the constructor arguments here, and then checking it's deployed. Then we're gonna have token contract. Then we're gonna say token. It's gonna grab the contract address here. Let me also change this to token. Okay. So we have our token contracts. This is going to be our attack flow still with a slight twist because first we want original balance of yep, we're gonna get our original balance and then the original balance is this. We're gonna call attack one. At least on the first go around, we're gonna call attack one, which should work. I don't know though. Yeah, so we're gonna say I want to see the balance. I want to call the transfer attack. And we're going to await attacker contract. We're going to call attack one. And we're going to pass in our attacker address. Okay. Yep. All right, and then we're gonna grab the balance of my attacker address after this transaction. It'd be cool to grab the balance. Grab the balance of the attack contract as well. Probably a little elaborate. Didn't have to do this. I could have just sent it to the contract address of the contract we're trying to attack. We're actually exploiting, but at least we'll have some more tokens in our contract. So grab the balance of the attack contract here. And we're gonna say that balance of attack equal to attacker contract dot address. And we're gonna say, we're gonna log this. And then lastly, we want to expect the balance to be greater than or equal to 20. Because essentially, well, actually, no. So if we do 23 here, message.sender minus value. So balance of message.sender minus equals this 23. Yeah, so that should underflow and give a really high value. So let's check it and just try it out. And I prefer this kind of attack because we're actually using an exploit contract for this. So let's rename this token exploit. Flowed. Check if balance successfully underflowed. All right, so let's go ahead and try to run this script. I'm gonna do contract. Nice. Both of them are gonna underflow. Because what happened is we passed, I believe I did attack 1, 23. Passing the value of 23, the balance of, interesting that this value for the attacker contract is high as well. Because I only thought that Let's balance the message to sender minus equals value. Let's try something. So this test runs. I'm kind of curious to see the balance of the attacker address. So let's take this all out. And then let's also comment out yeah, actually let's comment out all this. And then let's comment out this deployment. And let's just look at the balance. How's that 43? Oh, okay. I see. Because the message sender in this case is my exploit contract right here. And then yeah, so the message sender in this case is different. It's my attack contract. And then um oh, I wish I could transfer. Dang. I wish I could transfer. Oh, actually I can. I was supposed to call transfer again. Yeah, that would have been a better attack idea. Is once we transfer to the attack contract, we call one of these and transfer a bunch over. Where after the attack, we transfer this. Oh, let's see. Let's see. Let's back that up. We do this right here, and we transfer to attack, and then it's going to be this balance. Yep. Just so that when we transfer it back, it just doesn't cause any more other overflow issues. So let's try this. Oh. So let's get a new address. I mean, we would have passed this level, but I want all of this money. And if not, then what we could do, yeah, no, this should work. This attack one should work. I overflowed you, and then what we're gonna do is uh, reduce by 30. So we overflow back to original value. I'm just say it like by 50. All right, and then transfer this new high balance to attacker address. There we go. Interesting, because the first time I did this, I don't think I truly understood. I understood the overflow, but I don't think I understood how um, I was able to get such a high value. So let's try this, and we're going to deploy this again. So let's get a new address, a new instance address. Fun. So get new instance. Firm. That was like the old one. Okay. Let's replace this, that, and we're gonna uncomment out all of this stuff. Except for these. So grab the balance of my attacker address. Good. And then now we're going to it's still cool to get the balance of the token of the attack contract just to see what happens and then like kind of just see the story. And all right, now let's run this exploit again. I'm probably gonna run out of gas at some point after deploying all these contracts. All right, the original balance is this. All right. So all we did was transfer. So yeah, see, we got this overflow back to 50 because what do we do? We subtracted 50, and all it did was overflow. Oh, it was underflow back to that value. Interesting. Oh yeah. Okay, it just underflowed back to that value. And so we had this high number, subtracted 50 from that. And then if we subtract this high number, overflow number, minus the value of 50, then it will just cancel. Okay. So our attacker address has this really high one, which is what we want to see. And now let's go ahead and submit. Submit this instance. Let's confirm. I think I might have to confirm here, maybe. And let's get that sweet flag. Not seeing my flag. What's going on? There we go. All right, we completed that level. So let's go ahead and add. Oh wait, let's. I think I said telephone contract somewhere. The token contract is this. Okay. Challenge. Wait a minute. Oh, so I just added another one. Set upstream B token. Cool. All right, we finished that level. Let's see what we're at on time. About an hour and a half for this challenge. Learned a few things. So we learned what overflow is and underflow is. We learned how to exploit that, and we also learned about problem solidity updates with 0.8 so that this would just revert if we had this updated. Yeah, so we'll go to the next level and we'll complete that in the next stream. As always, feel free, if you watch this video later, just ping me if you have any questions.